Hello dear students, welcome back to the Mandawad Maths Academy. Now in the previous class we have seen the basic concepts of complex number and definition of complex number. In this class we are going to see the representation of a complex number in the form of a plus ib. So the given complex number, so that can be written in the form of a plus ib. Okay, the first question, so which so these examples which are depends on the exercise 1b. Okay. Now first question, express this given complex number in the form of a plus bi. The given complex number that can be converted into the a plus ib. So let us start. So the given, what is the given complex number? This 4 plus 2i divided by 1 minus 2i plus 3 plus 4i divided by 2 plus 3i. So this is given. Okay. Next step you can do here the rationalization, denominator rationalization. So whatever we have given in the denominator, here given 4 plus 2i divided by 1 minus 2i. So we take first we rationalize the denominator. What is denominator? 1 minus 2i. So we can do here rationalization, means 1 plus 2i multiply and divide 1 plus 2i. Similarly, same thing for this complex number, 3 plus 4i divided by 2 plus 3i into here 2 minus 3i divides 2 minus 3i. So this is one of complex number and this is another one. You can simplify this by using the rationalization. Is it okay? So next step, so numerator into numerator and denominator into denominator, means we have denominator 1 minus 2i and 1 plus 2i. What is numerator? 4 plus 2i, 1 plus 2i plus here 3 plus 4i into 2 minus 3i divides here 2 plus 3i and 2 minus 3i. So we know that formula, what is that? A minus b into a plus b. So that can be written as a square minus b square. A plus b into a minus b, that can be written as a square minus b square. So same thing you can do here. Here a minus b and a plus b. What is a? A is 1 and b is 2i. Means 1 square minus 2i square. Plus similarly here 2 square minus 3i square. So in this we already seen how to multiply this two complex numbers, means z1 into z2, how to multiply. So we take here this first component into first component, 4 ones are 4, and second component into second component, 2 twos are 4. Is it okay? This I square, means that is minus 1. Next plus here I outside. Next first component into last component. What is first? 4 twos are 8. Next second, third, 2 ones are 2. So this is a multiplication. Same thing you can do here. 3 twos are 6 minus 4 threes are 12. And this minus plus, then plus I, first last, 3 threes are 9, 3 threes are 9 and plus minus 4 twos are 8 plus 8. Is it okay? We can simplify. What we get? 4 minus 4, 0 plus I, 8 plus 2, 10. Is it okay? 0 plus 10i, 10i, 1 plus 4, 5, 8 minus I as it is, 4 plus 9, 13. So this 8 is real part and I is imaginary part. So you can don't do subtraction. Here you can do simplification, cross multiply. What we get? 10i into 13, 130i plus this 5 into 18 minus I, 5 into 18 minus I. Here denominator 18 into 5 into 13. So what we get? 130i plus 5 into 18, 40 carry 1, 5 on the 5 means 90 minus 5i divided by here 5 into 13. Is it okay? Next 130i minus 5i means 125i plus 90 divided by 5 into 13. So we can denominator separate the denominator. What we get? 125i divided by 5 into 13 plus 90 5 into 13. So 5 ones are 5 twos are 5 fives are. Here 5 ones are 5 eights are 90. So what do we get? Final answer is it visible? Yes. Now 25i plus 18 means 18 plus 25i divided by here denominator 13. So base is same. So your answer is 18 plus 25i divided by 13. Is it okay? Now this is second question. So what is second question? Find the real and imaginary part of the given complex number. So we have given complex number a plus ib and divided by a minus ib. So this is nothing but let us consider this z1 divided by z2. So how we can do one complex number divided by another? So you can do rationalization. Is it okay? Now we take this one and you can do rationalization. We get two terms, one is real part and another is imaginary part. So that is your required answer. Okay. Let's start. What is given here? A plus ib divided by a minus ib. So you can do rationalization. Now we take a plus ib divided by a minus ib. So how we can rationalize the denominator? Whatever sign here, you can take opposite of that, minus a plus ib divided by a plus ib. Multiply and divide by a plus ib. So we know that numerator into numerator, denominator into denominator. What is denominator? A minus ib, a plus ib means a minus b into a plus b. What we get? A square minus b square. What is b? ib. And here same thing, a plus ib, x into x. What is x into x? X square. Similarly, a plus ib, a plus ib whole square. Is it okay? Right? Next, a plus ib whole square means this is a plus b whole square. A plus b whole square, we know that a square plus b square plus 2ab. So here a square means first term square means a square plus b square means ib square plus 2 into a b. What is b? ib. This is a square, b square, 2ab, a square. Here I square is minus plus b square. You can do simplification. What we get here? Yes, a square, I square is minus 1 and b square plus 2abi means 2abi divided by a square plus b square. So we observe the numerator. So this is real part. So there is no I. So therefore this is real part and this is imaginary part. Now we can separate the denominator. A square minus b square divided by a square plus b square plus I. Here 2ab divided by a square plus b square. So what is this? This is the imaginary part. So therefore real part. Find the real. What is real part here? Real part is a square minus b square divided by a square plus b square. And what is imaginary part? Imaginary part is this 2ab divided by a square plus b square. So these are the required real part and imaginary part. Is it okay? If you are new to this channel, please subscribe the channel and forward it to your friends. This is third question. Express 1 minus I whole cube 1 plus I in the form of a plus ib. The given question that can be converted into the a plus ib. Okay. Let me take the given 1 minus I whole cube and 1 plus I. So we know that x cube can be written as x square into x. Am I right? Yes or no? Similarly, this whole cube can be written as 1 minus I whole square into 1 minus I, means this is x square and this is x. So another term is 1 plus I. Again we know that a minus b into a plus b is equals to a square minus b square. So what is a? A is 1 and b is I. A minus b, a plus b. So that can be converted into a square minus b square. Now this 1 minus I whole square can be written as 1 square plus I square minus 2 into 1 into I. So this a square b square minus 2ab, double of this. Here 1 square minus I square. 1 square is 1, I square is minus 1, minus here 2 into 1 2I. Here 1 square 1, I square is minus 1. Here plus 1 minus 1 cancel, what is remaining? Minus 2I into 1 plus 1. So 1 plus 1 is 2, minus 2I into 2. So your answer is minus 4I. So minus 4I, that can be written in the form of a plus ib, means here there is no real part. So we take the real part is 0, means that can be written as 0 plus minus 4I. So what is a? A is 0 and b is minus 4. So this is required that given question convert into the a plus ib. Is it okay? The next question. Find the multiplicative inverse of 7 plus 24i. 7 plus 24i is a complex number. In this, the value of a is 7 and b is 24. So we know that, let us consider, let z is equals to a plus ib, and the multiplicative inverse of this, multiplicative inverse of z is 1 by z. So we can find 1 by z, so we get the answer. So what is 1 by z? So this a plus ib, multiplicative inverse is a minus ib divided by a square plus b square. So this is the 1 by z. What is this? This is 1 by z. So is the multiplicative inverse of z. So what is the value of a here? A is 7 and b is 24. So you can substitute here. So we get the answer. Now therefore a minus ib divided by a square plus b square, means 7 minus 24i divided by 7 square plus 24 square. Here 7 minus 24i divided by 7 square is 49 plus, so this is 576. So what we get? 7 minus 24i divided by 49 plus this 576, here 625. So your answer is 7 by 625, one term, minus 24 by 625 psi. So this is the real part and this is imaginary part, and this is required multiplicative inverse of the given 7 plus 24. Is it okay? In another way you can find the multiplicative inverse of this. Z is the 7 comma 24 and multiplicative inverse 1 by z is 7 comma this 7 square plus 24 square comma minus 24 by 7 square plus 24 square. So we get answer is 7 by 49 plus 576 minus 24 by 49 plus 576. So we get 7 by here 625 comma minus 24 by 625. So this implies that 7 by 625 plus I 24 by 625. So this is required multiplicative inverse of the given question. You can find also like this. Okay. So the next question is very important. The given real part of z minus 4 divided by z minus 2i that equal to 0, find the locus of that z, means the value of x and y which satisfy this condition. So you can find the equation of the z. Okay. So let consider that z is equals to x plus iy. So we can find first this equation. So what is given? Given that z minus 4 by z minus 2i. Z is nothing but x plus iy minus 4 divides x plus iy minus 2i. So in this, what is real part? X minus 4. X minus 4 is the real part plus iy is the imaginary. Similarly, here x is real part plus y minus 2 is imaginary. Is it okay? So we can do here rationalization. We get the simple that can be in the form of a plus ib. So what is rationalization? Here x plus, so we take x minus y minus 2i. Similarly, here x minus y minus 2i. So numerator into numerator and denominator into denominator. So the denominator can be written in the form of a plus b a minus b. So that is a square minus b square. I square is nothing but plus. So here y minus 2 whole square. Numerator is first term into this bracket plus second term into this bracket. Okay, what is first term? X minus 4 into that bracket x minus y minus 2i plus second term iy into x minus y minus 2i divides. So this multiply with this bracket and we get this. There are two terms, one is imaginary, another is real part. So we get real part of that this number is equals to 0 we take, so we get the answer. Is it okay? We can simplify this, get answer. This x minus 4 into x minus 4 into x means x into x square, x into minus 4 minus 4x. Is it okay? Same thing, x minus 4 into this y minus 2 minus this minus y into xy minus y into 4 minus plus 4y minus 4 into y minus 2i. No need to multiply, we want only real part, so this as it is plus iy into xy I, this I square means plus, so y into y square minus y into 2 2y divided by x square plus y minus 2 whole square. So in this, so this is real part, am I right? This is real part. Similarly, this is also real part and this is imaginary part, this complete. So we write the real part together and imaginary part together. Now we get the answer. Now what is real part of this? Z minus 4 divided by Z minus 2i, the value of this is this x square minus 4x plus y square minus 2y. So this is real part. What is imaginary part? This one, xy minus x minus 4 y minus 2 and this I is outside divided by x square plus y minus 2 whole square. So you can do this, separate the denominator. What we get? X square minus 4x plus y square minus 2y divided by x square plus y minus 2 whole square. So this is a complete real part. Is it okay? Plus xy minus x minus 4 y minus 2 divided by x square plus y minus 2 whole square. So this is imaginary part. Now in this is a real part and this is imaginary part. Now we want only real part of z, this complex number is 0. So we have given real part of this z minus 4 divided by z minus 2i is equals to 0. So that implies that x square minus 4x plus y square minus 2y divided by x square plus y minus 2 whole square equal to 0. Means we don't require the imaginary part, we want here only real part of this complex number. Is it okay? So this is the real part. Now this become this side 0 into this, that becomes 0. That implies that x square plus y square minus 4x minus 2y equal to 0. So this is the required equation. Means this is required locus of z. Is it okay? Right. Thank you. If you like the videos, you can subscribe the channel and share to your friends for the more upcoming videos. So we are going to complete this complex number complete chapter. Thank you for watching these videos. Okay, thank you.